Okay, so today what we're gonna do is we're gonna go over some of these problems from the test. You can always learn from your own mistakes, right? And I think that's a really good opportunity for you to learn and don't make the same mistake next time. Okay? And for the final, you need to know everything from your previous test. Okay? So it is a good opportunity. Alright, so let's take a look at this. It's a little bit hard to read. It's small. I think I can make it. I can make it a little bit bigger. Is this okay? It's hard. Okay, a little bit better, right? Okay. So I don't know if you guys are familiar with Jamboard. Are you familiar with the Jamboard? It's one of the Google's feature that they use. It's very similar to Google Doc. So if you write something, whoever you are sharing that with can see that changes there too. So I think it's a really good tool when you are like doing collaboration work or solving problems together. You can see the person on the other hand, the other side, solving the problem there too. So that's one technology that I want to share. Today I'm going to use that one, okay? So let's look at this problem together. Let's see if I am sharing this. Right. Okay, I am. The graphic shows the amount of money spent in a country on video games played on mobile devices in 2013 and the projected amount for the years of 2014 through 2018. The graph here passes through the points 2013 and 2018. 2 points are given to you, right? So we're gonna use these to find this graph. So when you're looking at this graph, what kind of graph is this? Is it a parabola or a straight line? It's a straight line, right? So if you guys remember from high school algebra, we know it's linear graph, right? It's a linear graph. Linear graph has something like this, ax plus b, or maybe you're more familiar with y is equal to mx plus b, right? So you have only one degree of x variable there, and a and b or m and b, you need to find it out. So we call m or a as what? Slope. How much it is tilted. Okay, so we call this m and slope. And what do we call the b? Y-intercept. So what does that mean? Y-intercept. It's y value when x equals to 0. So when x is 0, so in our case, it's not 0, but it's 2013. And our y value is something here. Actually, we are given that number, 1099. So that is given here. If you have knowledge like this, I think it's really helpful to find, the projected number there. But even if you don't, I think we can find it too. So if we are doing this one, does anybody remember how to find the slope? We are given 2 points.
y2 minus y1 over x2.
There we go. So we are doing y2 minus y1 over x2 minus x1. What does that mean? That means you're going to find the change of y over change of x. Which one is y? These are y values, right? Did it increase or decrease? From 2013 to 2018, it increased. By how much? I saw some hands going to that. 400? Okay. 450? Thank you. What is it?
350.
350. Thank you. Oh yeah, actually it is. So 1449 minus 1099, it is, what is it? 350? 350 minus exchange. So 2018 minus 2013, 5, yeah, divide that, and what do you get? 70. So your slope is given, so we can change that slope. I'm going to erase this one, okay? Because it's the same thing. So the slope is 70. 70x plus, how about b? We already found it, right? That's y-intercept for our case is the price here in 2013, and it is given here, 1,099. So that is 1,099. So let me replace that with 1,099. So that's our graph. Okay? And what does it say here? Assuming this trend continues, so this trend continues, which means we can extend this linear graph here. Use the graph to predict the amount spent in the country on video games played on mobile devices in 2020. So 2 years later. 2 years later, where will that be? If you are using this graph, we can just plug in one number, 2019, 2020. If we are using this formula, we can see that, oh, this is 0, right? Because that's the year, the beginning year, and this is after 1 year after 2013. This is 2 years after 2013, 3 years after 2013, 4 years, 5 years, 6 years, 7 years. So we are figuring out 7 years after 2013, that's 2020, isn't it? So your x is 7. You can just plug it in and have 70 times 7, 400, what is it, 90? Plus 1,099, which is 9851. That 1,589. You can do it that way. If it's too much for you, you don't even have to do this. Let's suppose you don't know anything about a slope, y-intercept, linear graph, etc. Then what can you do? Here is another way that you can do it. Okay, another way that you can do is just use the graph. Okay, by plugging in these numbers. So this one here, it looks like to me 1100, but don't use that one. Don't use that one because it is already given here, right? So this value here is 1,099. This value up here. And on 2018, it's given as 1,449, right? Then what's the difference? You can find the difference and divide it by how much? 1, 2, 3, 4, 5, right? So you can find how much is increasing per year, right? So what's 1,449 minus 1,099, we already got that, was 350, right? So it increased by 350 over 5 years. So per year, we know it's gonna be increasing by divided by 5, 70, right? So after this, after 2018, we know that in 2019, it's gonna increase by 70. Then 2020, it's gonna be increasing by another 70, right? So you can add 140 to that, and that will be the answer for 2020. Does it make sense? Okay, so if you already know how to do the linear graph, course you can do it. If you don't, you can just predict by calculating whatever is given to us, by finding how much is increasing per year. Make sense? Does it make sense or not? I want to see your thumb. Okay, thank you. Okay. So these are the specific cases, right? To make the prediction, because we use the given numbers. It's not generalized. You are not given y is equal to, what was it, 7x plus 199. We don't have that. If you are already given this, it's gonna be inductive or deductive. It's gonna be deductive, but you are given the specific cases first, right? So it is now inductive reasoning. Okay? Right. Let's take a look at this one. Estimate the answer by rounding the first number to nearest 10. We're gonna round this to nearest 10. And the second number to nearest 100. Okay? So let's round this to the nearest 10. What's the 10th place here? I mean, just from here. 6, right? So I will underline that and look at the next digit, which is greater than 5. So we need to round that up, right? That is, you say it's 0.7 approximately. So when it's not exactly the same, you're not gonna put equal sign. Okay, it's not exactly equal. It's approximated. So you're gonna squiggle that equal sign. Okay, that's for estimation. Okay, so it's about 0.7. And now it says the second number to nearest 100. Which value is nearest? Which value is the 100th place? 4. So that's the 100th place. You're gonna look at the next digit, 6. Is it greater than or equal to 5 or less than 5? Greater. So you need to round that up. So it's gonna be 100, 1500. Now you can multiply those two together. Now I can put equal sign because I'm gonna multiply these two numbers and have equal number there. What is that? 0.7 times 1400, 1500. 1500 times 7 is 0, 5 times 7, 35. That's 10, right? But it's 0.7, so we need to drop 0, right? Because it was smaller. So 1050. Does it make sense? Okay. Next one, we're going to estimate again. It says estimate the answer by rounding the percent to the nearest 10. Nearest 10. So how do we change this percent? This is by ones, right? So you look at the percentage in 10th place. This is 10th place. And look at the next digit. It's smaller than 5. So we need to drop it, right? So drop it. And that's about what percent? 10%. So we rounded the percent to the nearest 10. And the second number to the nearest 1,000. Which one is 1,000th place? The 8. Here, 8. And look at the next digit. It's smaller than 5. So what do we do? Drop, right? So it's going to be of 8,000. So now we can calculate that. 10% into number. You divide this by 100, right? Because to get percentage, you need to multiply that by 100. To get this number, you're going to divide it by 100. So 10 divided by 100 is 1/10. 1/10 is 0.1, right? So 0.1 of times 8,000. What happens? The number was bigger or smaller? Smaller. So it's going to be 800 by one digit, right? Okay, so that's 800. Any question for that so far? Good? All right. 18%. We need to round this to the nearest 10. And this is 10th place. And I'm looking at the ones digit bigger than 5. So what do? We need to round up. So not 10, but it's going to be 20% of nearest 1,000. I'm looking at the next digit. it's smaller than 5 to drop 6,000. That is what's 20% into a number? 0.2. 0.2 of multiply and by 6,000. 2 times 6,000 is 12,000. So you have 0.2. So it's gonna be 1,200, right? 1,200. Are we good? Done? Okay, thank you. All right. The process of reasoning to a general conclusion through observation of specific cases is called inductive or deductive. Okay, let's go there again. The process of reasoning to a general conclusion. To a general conclusion from specific. What is it? Inductive. It's inductive reasoning. Okay. So when we are proving inductive reasoning, it's not easy because you need to show all the small cases there, right? So one way that we talked about is showing on an example to show that conclusion is not wrong. But showing that it is true is not easy for inductive reasoning because you cannot show all of the cases that make it true. Okay, here. After filling a gas tank, the odometer reads 57,491.9. After the next filling, it read 57,838.4. It's increasing, right? It took 17.5 gallons to fill the tank. And it's asking, this is important information too. How many miles per gallon? How many miles per gallon did the driver get? So it's asking miles per gallon. The hint is already given. Look, miles per gallon. Miles divided by gallon, right? How many miles? How many miles did he use? The difference between these two, isn't it? Yeah, so what's the difference? 57,838.4 minus 57,491.9. That's the difference. And for that, how much gas did he use? How many gallons? 17.5 gallons. Then we are done, right? So I will just use a calculator to do that. Whatever answer you have, that's the miles per gallon. Okay? So I don't have to do this part, right? Once you know how to do that, you can just use a calculator. Any question for this one? Okay. So that's the gas mileage. And how about if it's asking you the speed? We know that speed is mile per hour, right? So mile per hour means miles per hour, or that's same as miles divided by hour. We can always increase this knowledge by other things too. For example, let's say we are shopping and we want to compare the unit prices. Unit prices. How do we do that? Price per ounce, right? Dollar per ounce, cents per ounce. So what does that mean? Dollar per ounce or dollar per gallon, dollar per pound, whatever that is. You can just have money divided by the weight. Okay, you can always have the unit prices for that too. Okay, that's the similar concept. Does it make sense? Okay. Here, sequence. This is fun. Okay, we're gonna find the letter that will be entry on number 86. So 86th letter. So what do you see here? WG, 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 WG. It's just changing, alternating W with G, right? So it's kind of easy, right? So what we need to do here is we need to figure out, well, this is first number. So first number, third number, fifth, not number. First letter, third letter, fifth letter, seventh letter, ninth letter. All of these letters are what? Are numbers, and their letter is W. And even number terms, all of those are what? G. So if our number is odd number, the letter should be W. If it is even number, it should be G, right? So 86, what could that be? G, right? Okay, good. If I do some mathematics here, I can say this one too. So I see two numbers are alternating. Two numbers. So if I divide these numbers by 2, I'm going to look at what's the remainder. What's the remainder if I divide 1 by 2? 1. If I divide 3 by 2, 1. The remainder is always 1 for this one, right? So if your number has remainder of 1 when you divide that by 2, that should be W. And these numbers, what's the remainder? 0. If the remainder is 0, that should be letter G. Okay? Then we can increase that knowledge for this kind of a sequence. Now it's not that simple because we see we have one more letter repeating here, WFF. WFF. So you see that, oh, 3 letters are alternating like that. I mean, 2 letters, but 3 in sequence. Right? So we are grouping that 3. That means we're gonna divide each of these current numbers 4, 5, 6, 7, 8, 9, 10, 11, 12, and find the difference there. I mean the remainder there. For example, we know that 1, 4, 7, 10. These are the first number in each of the groups, right? So let's take a look at those numbers. 1, 4, 7, 10, next one will be 13. And we know that in each group there are 3, right? So if you divide these by 3, what will be the remainder? It's always 1. The remainder is always 1, right? If you are taking the second letter and third letter, you don't even have to do that because the rest of the numbers, it will be F, right? We just concern about that W. If we find it out, the rest of the numbers will be this F, right? So let's see what remainder we can have when we divide 117 by 3. 3 times 3 is 9, and we have 27. 3 times 9 is 27. So there is no remainder. What's the letter for that? It's F, because the remainder is not 1. If it is 1, it will be W. Otherwise, it will be F. Okay? Does it make sense? Okay. Before I do that, let me give you one more sequence then. How about this? You see the pattern? This is the sequence that is given to you, and I want you to find 102nd number, letter. Okay, everybody solve for this. What letter is 102nd? How did you know, Levy?
Because when you divide 102 by 4, your remainder is going to be 2.
Yeah, very good. So we can see that we're gonna group these as 4 because this is repeating, right? So we know that we can divide this by 4. And let's see. If we divide any number like 1, this is first number, that's the fifth number, that's the what? 9? 1, 5, 159, all of these numbers, 159, 13, all of these numbers are, when we are dividing this by 4, what's the remainder? It's always 1. If the remainder is 1, it will be A. Otherwise, it will be B. Right? And divide 102 by 4 then. What's 102 divided by 4? It's there. 5 is 20, so remainder is 2. Is the remainder 1? No, it's not. So that's B, right? Does it make sense? Everybody? Okay. Good. Let's go back. This is the last problem that we're going to do. The tuition at a certain college was $24,680 last year, and it increased by 5.7% from last year to the current year. So, yeah, of course it's increasing. It never decreases, right? Too bad for you guys, but I know. But anyways, how much is the year's tuition? So we know that intuitively you can say that, oh, it would be more than 24,680. If your answer is less than that, something is wrong, right? And think about it. If we are increasing that by 5.7%, well, we can think about we are paying 24,680 plus some increase there, right? So how much will be increased? It says 5.7% of the previous one of 24,680. Does this make sense? This is only the increase. So, or the other way, in other words, it's the difference between this year and last year, right? So we can just calculate that now then. How can we calculate this one? 5.7% times 24,680. 5.7%, let's change that to a number. How do we do that? Yeah, how do we do that? To the left by 2 digits, because we are dividing this by 100. Divided by 10, we make it 1 place value, but divided by 100, 2 place value, right? To the left. So where does that decimal point go? Here. It's 0.057. I think some of you made a mistake about this as 0.57 or something else. So once you set it up correctly, I don't think it has any problem to do that. 0.057, right? Times 24608. If you're punching the calculator with this order, it's gonna give you the wrong answer because your calculator is dumb. It's not graphic calculator. It doesn't know about ordinal operation. You have to do that part. Which one do you need to calculate first? Addition or multiplication? Multiplication. So when you're using your calculator, you need to operate this first. Then add this. If you are doing addition first, then for multiplication in yours, they're gonna add these two, then multiply the sum by that that factor. Then you're gonna have the wrong answer. Okay? So make sure you do multiplication before you add. All right? Are we good? Okay, I think that's about it. If you have any other question, please visit me and let me know. Okay, we are moving on to now chapter 2. Okay? I know you don't want to do that, but we will. Okay, so here we go. Chapter 2 is about sex. Okay, so we're going to talk about sex and section 1. Okay, let's start with the definitions of a set. What is a set? A set is a collection of objects. Okay? So we can say a set of math 137. What's in it? We are in it, so we are the element. So we can name our set, our group, as math 137. Okay? So a set is a collection of objects, and the objects, what's inside of the set is called elements. Okay, elements. So for example, a set can be described as a list. For example, capital D, usually we put capital letter for the set name. Okay, and we use lowercase for the elements. We distinguish those two. So D is the name of the set. So set D is equal to, in the bracket, we can put braces, 5, 6, 7. So the set is D. The elements of set D is 5, 6, and 7. Okay? Kind of obvious, right? Okay. And we can list that way, then we call this as roster form because we have all the list there. So for example, I say our set of math 137, I can put all your names in order. I can list them, right? Just like these. But I can also describe what it is. I can also say it is math 137 students at Chevron. That includes all of us here too, right? Okay, so I can do two different ways. And when I also describe it, I can do two different ways too. So let's compare these two. These are exactly the same thing, but the way how I describe is different. One way, all whole numbers between 5 and 7, inclusive. What does that mean? Inclusive. We're including these two numbers, 5 and 7. So we are doing all whole numbers between 5 and 7 inclusive, meaning we are doing all the numbers in between 5 and 7, so 6, but we are including 5 and 7 too, so 5, 6, 7, right? Or we can say that all integers bigger than 5 and less than 8. We can change these integers for whole numbers, but it's the same thing. All whole number bigger than 4, so 4 is not included. Less than 8, 8 is not included, right? So whether you use inclusive or not is a big difference. Okay? Or you can also say this one as all whole numbers between 5 and 7 without saying inclusive. I mean 4 and 7 without saying inclusive. That's the same thing. Okay? Make sense? Okay, math is to indicate a set. So description of sets. You can just describe it, what it means. Okay? So for example, can we describe a set containing the elements of January, February, March, April, May, June, July, August, September, October, November, and December? These are the elements. And how can I describe these elements?
Months of the year.
Say it again.
Months of the year.
The month of the year. So I can just say, oh, the set is equal to month of the year. Then that means you can list all of these months, right? So either way it works. Good. So we put set with braces. And if you have a list of them, it is roster form, right? Like that. When you are using the roster form, if the elements are repeating, you don't have to rewrite that again and again. So it's the same as this 5, 6, and 7. And the order doesn't matter. 5, 6, 7 is the same as 6, 5, 7. Because still in the braces you have all those 3 elements, right? You still have those 5, 6, 7 elements. Why do we write it this way though? Because we can systematically look at that and we can easily do something with it. If it is all mixed up in different order, it kind of makes us confused. That's why we are just writing in order. but these are exactly same. We call them equal sets. Equal sets. So if I say my set is month of the year, and I say another set B is January, February, December. They are exactly the same thing, right? So we say those two sets are equivalent. I mean, equal. They are equal sets. Equal sets. And I just prefer say equivalent sets, right? The equivalent sets are a little bit different from equal sets. Equal sets have exactly same element, but equivalent set has exactly same number of elements. Same number of elements. So for example, if set A has January, February, March, so there are 3 elements in it, right? And another set B has elements of April, May, June, 4 different elements. The number of elements are same for both are 3. Then we call that not equal, but equivalent set. Okay, to distinguish equivalent from equal. Okay, all right. Let's talk about some natural, the number system. So, did I mention about this natural number, whole number, etc. in our class yet? Okay, let me briefly say that. So our number system is real number system. So whichever number you say, it's real number. But inside it, we can have a lot of different sets. So usually we start from natural number. So when you see babies, they start from counting, right? When they're counting, how do they start with? 1, 2, 3, 4. They count 1, 2, 3, 4, right? So the counting numbers are natural numbers, we say. And they are 1, 2, 3, 4, 5, 6, 7, 8. Those are natural numbers. Okay? They are counting numbers. And when they go a little bit older, like preschool, we add the concept of 0 to it. Okay? 0 means there's nothing, no element. Okay, so that is a whole number. A whole number. And when they go to upper elementary school, we increase this system to integers. So now we talk about the negative concept. -1, -2, -3, etc. But as you can see, whole number is not only 0, but also natural number. So this set is part of whole number set. And you can see that whole number set is a part of integer set. An integer set is a part of rational number. Rational numbers are any number that you can change the form of a fraction. So -1 is -12/2, -3/3, etc. All of these numbers can be written as fraction. Also like 1/2, 0.3, repeated. These are all, can be written as fractions because this is the same as 1/3, right? Etc. But there are some numbers that you cannot write as fractions. What do we call that? Irrational number. So anything outside of here should be irrational number, including both of that. We say that it is real number. Real number. Any number like pi, we cannot change that to fraction, right? Square root of 2, negative square root of 3. These numbers cannot be written as fraction. So we're gonna talk a lot about these. Okay, so you need to know when we're saying natural number, what does that mean? It's counting numbers, whole numbers, include 0, no negatives, integers. You are having positive integer, negative integer, and 0. Okay, and so on and so on. Okay, that would be very useful when we're doing the stats. So please keep that in mind. So natural numbers are counting numbers, 1, 2, 3, 4, 5, Okay, now we can do some examples here. Okay, raster form of sets. Raster form, we know that we need to list the elements, right? Okay, so on your notebook, please write set A with a capital letter is the set of natural numbers less than 6. Less than 6. Natural number less than 6. Set B is the set of natural numbers less than or equal to 45. Less than or equal to 45. Again, this is raster form. You need to list all the numbers there. Set P is the set of planets in Earth's solar system. So part C is integration with math and science. Isn't it nice? Math is always integratable with other subjects. Think about it. You guys can talk about this with your neighbor. I strongly encourage you to do so. And I will just call your name randomly. Shana? Set of 8.
Set of A with 2. 1, 2, 3, 4, 5.
Not including 6, because the numbers have to be less than 6, right? Very good. So I'm pretty sure you all have 1, 2, 3, 4, 5 in the braces with the commas in between, right? How about set B? Can I have Elizabeth?
It's just the braces and then 1 through 45.
1, 2, 3, 4, 1 through 45. So 1, 2, 3, you can put dot, dot, dot there, right?
Yeah.
And put comma and 45. Dot, dot, dot means all natural numbers in it. Very good. So you need to put some, examples there. So I will suggest you to write at least 4, 5, 6 numbers in it. Because don't just put 1 comma, dot, 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 comma, 45. It's not good because we don't know what that means, right? You need to give a little bit more examples in the list. Good. How about C? Is there any volunteer for that? Yeah, Rachel? No.
Audrey.
Audrey. Okay, Audrey, please.
All right.
Rachel is you.
Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, and Uranus.
There we go. Pluto is not anymore considered as the planet. Yeah. Okay, so if you haven't put in Pluto, you should be as old as I am. Okay, are we good? So we have answers here. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Does this order matter? No, it doesn't. Because it's still equal set, okay? How about this one? Word inclusive. We already know inclusive means, right? So can you express the following in raster form? The set of natural numbers between 7 and 12. I think you can already do that, right? Ramsey?
The set of numbers, the natural numbers between 7 and 12, and between 7 and 11.
So say that out loud.
8, 9, 10, 11.
There we go. So 7 and 12 are not included, right? So 8, 9, 10, 11 are the only elements in that set. Excellent. How about this one? The set of natural numbers between 7 and 12 inclusive. Inclusive. Camden?
Would be 7, 8, 9, 10, 11, 12.
There we go. Okay, so you're gonna include the 7 and 12. Good? Okay, I don't think you guys have a question for that. Here is notation. This is very important, okay? So, this notation is between the element and the set. Okay, this notation again is between element and set. And just like a greater than, smaller than, those, you see that mouth is opening for the bigger side, right? So if you can relate that, we see that this is bigger sign, right? The set is bigger than element, because it includes the elements, right? You can see that this means 5 is an element of E. 2 is not element of E. Not bad, right? So you need to know the notation here for elements. Later, we're gonna talk about how about then between the sets. How can we denote them? So for example, let's say set A has 1, 2, 3, and set B has 1, 2, 3, 4. Okay, so we know that 3 go with 4. 4 is an element of set B, right? 4 is not element of set A, right? Now, we know that this notation is between element and the set. How about between set and set? Oh, I see that this set is part of this set. All of these elements are in this set. So I see that these elements are all set A. So A is subset of B. Then we don't need that small bar in it, because it's between the sets. Okay, so this is between element and the set. So we distinguish them? Okay. Alright, we're almost done. Let's finish this one. Equal set, I already talked about it, right? When you have exactly same elements in it. So we say two sets are equal if they consist of exactly the same elements. For example, set A is Major League Baseball players who hit more than 760 home runs in their career. Set B, Major League Baseball players who hit more than 70 home runs in a single season. I have no idea about the baseball. But they said that person is only Barry Bonds. I don't even know who Barry Bonds is. Okay, so we can say these two sets, even though the descriptions are different, their element is the same, right? So we say that they are equal sets. Okay, so let's finish it here, because equal sets, we're gonna finish the definition here. The equal sets mean we can say they are equal, two sets are equal. Which means they contain the same elements. Okay? Alright, that's it guys. And homework for this one is not due by Monday because we are not.